So good evening, everyone, and welcome to the Jenks Center evening and weekend programming. The Jenks Center is located in Winchester, Massachusetts. Just some information, some housekeeping. If you don't receive our e-newsletter, you can sign up for that. Be advised that tonight's presentation is being recorded. If you don't want to appear, then you could turn your camera off now. And thank you for that. You may be asked to participate in a survey. This is part of our grant that has funded this evening. So the rest of the programming for June is Dancers Dialogue with guest Deborah Boyle. She is at Ballet Arts in Winchester, Massachusetts. She is running a ballet studio there. And she will be interviewed. One moment, I'm just admitting someone in. She will be interviewed by Pamela Weiss, who's a ballerina and contemporary dancer. And then in July, we have Summer Backyard Birds with Neil Hayward. He helps us to realize what's in our backyard and what sounds we're hearing and who is singing them. So he's very interesting. We have Decorating with Color by Stacy Martin. She is an interior designer and will help us to figure out how to do a splash of color in our interiors. So then we have Composer's Corner with host Andrew Celentano and guest Paul Hartung. That's July 13th. We have the Beatles Sing-Along with Diane Therese on July 17th. Diane has come once before and done a performance of revolutionary songs from the American Revolution. Then we have the Cape Cod Journals of Henry David Thoreau, presented by historian Richard Smith, and that will be July 20th. We have Car Racing with Jim Shaw on July 27th. So I want to thank the Cummings Foundation for their wonderful grant that has allowed us to have 3 years of evening and weekend programming at the Jenks Center. And I also want to thank them for our next grant, which will span 10 years. And we are just so thankful for them awarding us that. And that brings us to this evening, which is a shop tour with locomotive builder Ed Hume. And I'm going to turn this over to our host, Andrew Celentano, and Dr. Ed Hume. I'll stop sharing and I will turn it over to them. So thank you for being here this evening.
Thank you, Hillary.
Very pleased to be here.
I'm going to spotlight, bring in Ed here. Okay, excellent. Ed, thank you so much. You know, I saw Ed in an alumni bulletin, magazine or bulletin, and it was a wonderful article. And I thought, oh my God, I should call this guy up and see if he'd be kind enough to be in our show. And Ed kindly agreed. And I'm just fascinated by the work you do, Ed. Let's talk a little bit about your background. How did you end up getting into the whole world of science? I mean, you went to MIT. Do you remember that seminal moment when you were a child where suddenly you thought, I think I'm going to be, you know, an MIT guy? You know, was there a moment in your life when suddenly it all came together for you, or?
You know, I'd have to say that I wasn't thinking about things like that a lot, but I was in a, you know, they had what they called advanced classes, or, you know, in some regions of the country, they call them gifted and talented.
Right.
And so it was actually another kid in the class that said, you know, you like science so much, you know, maybe you'll go to a place like MIT someday. And that was probably, you know, like 6th grade. But I, you know, I got to point out that I went to MIT as a grad student.
Yes, right.
And I did my undergrad work at that other place down the river.
Yeah, we won't hold that against you. Excellent. And then, you know, I talked to you earlier, of course, and one of the things I was fascinated by, I just assumed, and this is bad on my part, I assumed that you had this big train layout in your basement as a kid, and, you know, you probably had all these different feet, and that's not who you were as a kid, right? You had a train set, but you put it away like everyone else did, and, you know, true,
yeah,
right?
I can remember, you know, asking my dad to drive me to the hobby store when I was like maybe, sixth grade, fifth grade, seventh grade.
Yeah.
And I did have some N scale locomotives and rolling stock and like modular snap together track. And it was just, in a cardboard box and, pull it out and fiddle around with it on occasion. But no, it wasn't kind of the big basement, layout, making buildings and all that. No,
Right.
that wasn't us.
The other thing I'm fascinated about you is you didn't study mechanical engineering in college. You studied chemical engineering, true?
That's right. Yeah.
Yeah. So this is mechanical engineering thing's a whole different hobby for you. And I should also add that you started your own business in the software business. I believe you still have a consulting deal on the side on that, true?
Yeah, it's mostly a product company where I get licensing revenue and not so much consulting anymore.
Okay.
It did take a lot of consulting work over 10 years or so to kind of get the company established.
Sure. Well, and it's in the space of machining and that sort of thing, true? It's in the CNC machines and that sort of thing?
The software business? No, not at all. It's
not. Okay.
Semiconductor, it's control, supervisory control and communication with semiconductor equipment.
Oh, okay. All right. Excellent.
And,
thank you for that.
Factories will use the software to make sure their tools are set up properly and processing properly.
Yeah. Well, do you think we should start? Perhaps we could start with a tour of your facility there and show us some of the machines. Would you like to start there? Or?
Yeah, I think that's probably we promised everybody kind of an idea of what kind of tools and things, and I've picked up my computer and I've got some of my locomotives out, and we'll be talking about those, and but let's hit some of the big machines, and what you see behind the locomotive models is what is called a CNC mill, and I'm gonna move my hand and show you. Basically, a cutting tool is inserted in the spindle, and over here on the desk, I've got a selection of cutting tools. I have drill chucks that can hold drills, and I have other holders that will hold what's called an end mill, which is something like a router bit that can cut away and leave a flat pattern. So this is a very versatile computer controlled system where under computer control, the spindle can come down or back up, and the XY table can move around in X and Y. And so you can do things like profile cut curves and level off surfaces. Cutting the curves like that is something you can't do easily manually. You need something like a circular table. So I am going to just walk by some of the other shop equipment, and I'm not going to dwell too long on some of the smaller tools, but this is called slip rolls, and this is used to bend metal into like curves, which you need for like a cab roof of a locomotive. And this little baby here it can grab the metal in there, and then you can like bend it into a right angle or any other angle less. This is a tool that can cut off, shear off a piece of metal, or it can cut out a corner. And if you take a little piece of aluminum and you cut out 4 corners, you can bend it into like a little chassis box. This is a jigsaw, and I can actually use it to cut thin pieces of like copper, like for boilers and things. Most people that have this kind of tool will use it for woodworking. And I'm sure you've heard of like a jigsaw puzzle, and this is a jigsaw. That's
sure.
That's where that comes from. And then I've got a grinder, which is mostly for sharpening tools that I chisels or tools I use on the lathe, a belt sander, good for, grinding away at something at a slower rate. And this is in the old hobby literature, the lathe is usually referred to as like the queen of the shop.
Yeah.
Because the old, the old guys didn't have like the CNC mills or the I'm going to show you a manual mill next.
Right.
And so they did a lot of work that a modern machinist would do on a mill. They would do it on the lathe, by adding various attachments.
Mm-hmm.
But to give you a feel for how the lathe is used, the work that you're going to machine is held in this a chuck, and there's different kinds of chucks, to hold various size things, or to hold things off center and stuff. And then the spindle will turn this at say 1,000 RPM, and cutting tools are brought up, and I'm kind of juggling everything around, so forgive me for shaking, but cutting tools are moved in and out to like smooth off the ends. And I've got a digital readout system here that can show me to like 0.2 of a thousandth of an inch where the position is of my cutting tool.
That's great.
So I can like move over 1/4 inch and cut a piece off,
mm-hmm.
And know that the feature that I was working on is very nearly 1/4 inch.
Mm-hmm.
And so this is the last of the real major tools that I can't let you guys escape without seeing.
Sure.
And this is a vertical mill, and this is a good old American Bridgeport from Connecticut.
Mm-hmm.
And it's like the computer controlled one. It's got a spindle, and I can put drills in there. It's like a router on steroids in some way for guys that do woodworking. And this is my Z axis. I've got like 4 or 5 inches here, and I can move the whole table up and down. It's called a knee mill. There's a crank that the table's like 4 foot wide, and I don't know what that's about 12 inches deep.
Mm-hmm.
You clamp things. You have a vise typically to hold something, or you clamp your work to the table, and then you sweep it by an X and Y. If you got an end mill and you're cutting a groove, or you're leveling off, or you move it around to X and Y, and you come down in Z if you're drilling. And again, I've got a very sensitive digital readout system that's accurate to 0.2 of a thou. And so when I'm making parts for a locomotive, I always try to make it to within 1,000th of an inch of the design or the plan.
Right.
Even though most of the time that level of precision is not needed.
Mm-hmm.
And so it's kind of an entertaining game, to see how close you can get.
Yeah.
And then when you, on a critical part like the fit of a shaft in a hole, when you really do need that kind of precision, that's been routine for you. So, you really are going to hit it,
Exactly.
because that's what you practice.
And you've got some very precise components, obviously. And we'll get into some more detail on some of those as you wish. By the way, just before I forget, I just posted your Flickr site on the chat section of this Zoom engagement. And I'd like to suggest to the audience, if you want to ask some questions in the chat, I'll field those on occasion when it makes sense. And we'll also have a Q&A at the end. Okay. So Ed, which was the locomotive? I think the first one took you about 5 years. Is that true? Was it the first one?
Yeah. But the story begins even before that locomotive. This is what Andrew's asking about. This was the first locomotive I built,
mm-hmm.
and it took about 5 years because I was learning how to machine. I'm basically a self-taught machinist.
Yeah.
And I didn't have the nice tools that you see here today.
Oh, really?
I started with a 1942, war surplus South Bend lathe that was almost
Uh-huh.
worn out.
Yeah.
And instead of the beautiful vertical mill, which I got in the height of the dot-com boom, I
Mm.
had what's called a mill drill, which it's similar, but it will not go up and down in Z as far with the same precision. You
Yeah.
have to keep, you can move it 5 inches precisely, and then you have to like basically find your coordinate system again.
Wow.
Um, and but you don't start out building something like that locomotive. This is like what the kind of motor that I really started with. It's a little wobbler engine,
Mm-hmm.
and it was based on a plan and originally published in Live Steam magazine, and then available in some of the books that Village Press sells.
Mm-hmm.
And so it's like little projects like this where you don't have much material at risk is where you do your learning. And so that was like engine number one. And then engine number two was published in Live Steam magazine, the plans for it. And it's there's a lot more time taken to have this beautiful flywheel, and the engine frame are made from aluminum and milled out.
That's beautiful. By the way,
So
I just remembered that you wrote a book on the whole. Uh, which one was that?
that's my latest locomotive.
The Climax class steam locomotive model. And so I actually just posted that on Amazon.
Okay.
I posted that link as well for the audience to see.
Okay, I actually just by some strange coincidence have a copy of the book out.
Okay.
It's maybe you could post a link on Amazon there for people that are interested.
I did do that. Yeah. And of course, just really briefly, we saw the railroad car with the two robots, so that we might see near the end, perhaps at some point.
Oh yeah, we can whenever you want to see them.
Sure.
You're spinning through different topics here. This is the Climax A locomotive that's featured in the book.
Mm-hmm.
And looks like the lighting's a little tricky, like it's.
Oh, there we go. Yep, that's better. Yeah.
And so this was that's my latest locomotive, and this is after years of working on locomotive models that were very closely based on designs published by Kozo Hiraoka, who is from Japan and has published designs on building the Shea and Climax and Heisler. I basically took my learning and took his techniques and repackaged them into building an old-fashioned Climax locomotive. The model, this is the Model A, Class A Climax, and so this one has got some kind of interesting features. It's got an upright motor that's kind of small and difficult to see for you guys. And there's a lot of pictures on Flickr that show how I made many of the parts that went into these. And they're, you'll be able to see and understand, the various parts and assemblies, because as I was making them, I was taking nice high resolution photos and things.
Yes, excellent.
And so that Flickr site, why don't we go to that Flickr, because I can show like the Shea running and
sure,
give people a feel for that.
By the way, while you're doing that, I like the fact too that you actually build a nice case for these as well, that holds them in place, and also you have on one side it folds down and you have the railroad that can I guess you slide it right out on the railroad there.
Yeah, it's a ramp that when you're running the locomotive, it's hot. I'm moving my hands like I'm still off the screen, but I'm not. So
that's okay.
Somebody goes to that link,
Mm-hmm.
they'll come into this view, which is like my photo stream, which is organized by date, and the newest stuff is at the top. So the things I've been working on lately, which is a lot of work with 3D plastics printing, is near the top. Then if they click on albums, I've got my work on various more like Live Steam and Locomotive projects. I have things more organized by project under album. So there's a lot of pictures of building the Climax Class A. We'll come back to the hand car because we got a SpongeBob robot, that's just runs the hand car. Is really cool. And the Shay is this was a 5-year build, and I departed from Kozo Hirooka's plans pretty substantially. I'm moving my mouse. I guess I'll click on this.
Yes.
This is the original magazine, original design that Kozo Hirooka published, and it's for 3.5-inch track gauge, and it's got the water tank is on the same frame as the Locomotive, main cab and boiler and motor, and I modified his plan substantially. And so this was before I was doing 3D CAD, but I basically added another truck and an extra water tender, and I had to reproportion everything to make it work as a model of a narrow gauge locomotive, which means instead of being the kind of track size that modern railroads use, they were only 3 feet wide. And I'm scrolling through things very quickly, and if the person that's interested can come back to the Flickr pages and go step by step. And I just zoomed to the end because I wanted to maybe start with showing the locomotive running when it was all completed.
Sure.
And this is a view of the locomotive. Is only about 1.5 minutes. This is running at a park in Houston, Zube Park, where the Houston area live steamers have built a track. And this is the size of track here is gauge 1, which is 45 millimeters. Now this is a real working locomotive. And the gray can in the car there is butane camp stove fuel, and it's it's being burned underneath the boiler. It travels through the smoke tubes and out the stack, and it's a very clean burning flame. So we're not seeing a lot of smoke. You'd see steam on a cold day or a moist day. And the Shay is an attractive locomotive because all the motor and mechanism is on the outside there, so you can watch it as it goes by. I guess we can stop. Okay.
That crankshaft is amazing. I'd love to see more on that. Yeah.
Yeah. These little pipes on the motor are they're actually drain cocks for to drain water when the locomotive first starts up at school. And you mentioned the crankshaft, and I had some. There was a story when I first made the crankshaft. It's really quite a bit of work.
Yeah.
And it actually was bent slightly. It was not the shafts at the parts of the shaft that were supposed to ride in bearings. You could see a little gap of light there, and I had to understand that their crankshaft was not straight. And then I came up with a scheme to bend it back straight. And I could show like this is kind of an interesting little, minute and a half or whatever of breaking in the motor, and I'm using a cordless drill to actually run the motor. And as it's running, I'll explain a little about valve gear, which
Sure.
is this shaft here. These little arms are attached to that shaft, and the shaft can pivot to set the valve gear position.
Hello, today is February 10th, and I thought I'd give you a view of breaking in my Shea motor. I'm running the motor action with a cordless drill. As seen from the back, I'm connected to the rear coupler. I'm going turning the shaft in a clockwise direction, which corresponds to the locomotive running in reverse. The valve gear along the front, the rod along the front that holds links reaches in and sets the forward and reverse positions on the valve gear. And the right now they tend to find a path of least resistance by shifting into the proper position for whichever way you're driving the crankshaft. I'm going to reverse the motor now, and this will be now it will take it in the direction of the locomotive moving forward, and you'll see the valve gear reposition itself to correspond to like a forward valve settings. So here we go. The valve gear shifted. It found a position of least resistance, and I'm running this under a cordless drill to the motion is somewhat stiff, and as I run it more and more, it becomes looser. It'll be easier for the steam power to drive the locomotive. So you would call this breaking in, and once I'm confident that it's smooth enough, I'll break it in under steam power, running the locomotive on rollers, and but this just gives you a feel for some of the activity that goes on behind the scenes to make a smooth running locomotive model that will run well in the field. There's a lot of work that you don't see when you go to the steam up. So until next time, we'll see you.
That's quite an achievement there. Ed, could you kind of describe a little more, if you don't mind showing that picture just for another second or two? Can you show the end of that? Just so we can, yeah, just
okay,
show,
sure.
yeah, just like that. So you've got these three main cam movements that I assume are like the pistons, and then you have these other smaller movements that look like they're controlling valve work. And so is that?
Yeah, exactly. You're seeing three sections, and this is like a rod that is connected to the piston.
Mm-hmm.
So these are the three cylinders, and so this is where the power is being transferred to the crankshaft.
Mm-hmm.
And then during the film, I'm talking up the rotation of this shaft, which is changing the valve positions for forward and reverse.
Mm-hmm.
And let's look at that in a little more detail. There's for each cylinder, there's two eccentrics and two pieces of bronze eccentric straps. And when I show another view of the crankshaft, you'll see the forward and the reverse eccentrics on the crankshaft. And so when this shaft is rotated, it's lining up an arm with one or other of the eccentrics, and one eccentric, and this is per cylinder. One eccentric has the timing correct for going forward, and the other one has the timing correct for going backwards.
Ah, okay.
And so that's why the engine's reversible.
Wow, that's great.
If I get another view of the crankshaft, I think I'm making it on the previous page. Okay, so here's a view we were looking at. These
Yeah,
Where
those are
I'm
the
moving my
eccentrics.
mouse,
Yep,
those are the eccentrics, and one of them's for forward and one of them's for reverse.
got it.
Then the pistons are here, on these arms. And so here's another set of eccentrics in the middle, and the last set of eccentrics is on the right. And there's actually another eccentric here, which is running an oil pump.
Ah, okay.
And so that's something I added to the plan, that did not exist in Kozo's design.
Huh. By the
Um,
way, I believe you have Kozo as an option in your album you have a separate connection to him, true?
I've been fortunate enough with my professional software work. I've been over to Japan initially to visit him, but I do have a folder of his locomotives and visiting him in Japan.
Yes, there you go.
And so this
Oh,
is
wow.
actually a cool boat in the
Mm.
the harbor, and we saw some sumo wrestling.
Oh my, that's great.
And this is the master. This is Kozo-san.
Hmm.
And believe it or not, his drawings are not based on CAD. He hand draws every little rivet, every little screw
Wow.
on these wonderfully detailed plans.
Hmm.
So this is one of my favorite pictures. He's designed and built each of the three main geared locomotives.
Mm.
This is a Heisler locomotive, which is like a V2 engine. The cylinders come out at 45 degrees.
Hmm.
And this is the Shay, and you can just get a hint of seeing the cylinders like you saw on mine. And this other engine is a Climax. And instead of having the pistons connect to the driving wheels, which is what you have on a typical rod engine, they connect to a shaft, which is geared for more power to a shaft that drives the trucks.
Yeah.
And
wow, that's
so
impressive.
there's just all kinds of pictures for anyone that wants to plow into more detail on these.
Yeah.
And because I've built more Kozo style locomotives than Kozo has, because I've built each one that he's built, and then I built my Climax Class A.
I love it.
Which is using his design techniques and things.
And there's two things I'd like to show the audience, if you don't mind. I'd like to show them the bevel gear mill work that you did, because that is a complex design.
Okay,
and,
sure.
And then also that sand cap, I forget what you call that, but that was a complex interface that you designed and built mathematically, which is
okay, sure.
Quite challenging.
I just changed locomotive models on you now.
Okay.
And this is the
that's allowed.
This is the Climax Class A.
Yeah.
And this is going through the whole story of how it was built.
Mm-hmm.
And so, we got the wheels built. Now we're working on the gears. And so basically created blanks for the gears on the lathe. And then this is a little fixture that created holes in them so that when I put them on a holder, those holes ensure that I can put them exactly back in the same position.
Yeah.
And
do you want to show us a sample of the two different gear assemblies? There's a simple bevel gear where the axis is directly over the other, and then there's and there's the complex one right above. That's those curves are really quite complex. Yep.
So what I'm talking about with the Climax A, these are skew bevel gears, and the shaft of the shafts are not in the same plane. And so with the locomotive, this meant that the drive shaft for the trucks could pass above the truck axle. And with the ordinary bevel gears like the Shay features, I'll stop sharing. And
this is great. Yes, that's great. Thank you.
These are ordinary bevel gears, and this is a little test jig that I can, after machining gears, that I can make sure that they're going to mesh smoothly. I got all my dimensions right. So this is the kind of gears used on the Shay, and the fact that the shafts cross over each other means that on the Shay locomotive, the power shaft ran along the outside of the locomotive, and so the shaft and pinions ran along the outside of the locomotive, and the big gear that was connected to the axle was at the end of each axle.
Yeah.
And so the Shay had no choice but to have the shaft on the outside, and that made for uneven weight distribution. And I'm told that it even wears out the track under the motor and faster. And then this is the difference with skew bevel gears. There's far more complicated math to figure out, how to have the gears, how to cut the teeth so they're off center and they're gonna mesh smoothly. And what I understand is the gears that I've made for my model based on Kozo Hirooka's development of a technique to machine these gears. These are actually better characterized in mathematical terms than what they had when they made the prototype locomotive. I'm told they'd have the old guy in the foundry area carve up pieces of wood and file and sand till they had masters for casting. And so they would do that iteratively by, testing the fit, filing off a little more here, sanding there. And then they would prepare castings. And, we, in the book and in the pictures, I show a complete process for making these kind of gears with a CNC mill and a rotary table that's indexing one gear tooth at a time, for the next cut. Yeah, that's quite a story that, we actually have more precise gears than they had in the prototype days.
That's amazing. That's amazing. Now, another mathematical challenge you had was what do you call it, a sand cap?
Oh yeah, the sand dome on the Shay.
Sand dome, yeah.
Okay, let me go back to screen sharing here. And let's see here, share. And we're going to go back to my albums and go into the Shay. And here we go. And then let's see, I think that's pretty far into the locomotive build. Let's see if we're lucky. Yeah, here we go. This is the part we're discussing is the sand dome, and it sits on an oblique conical solid. This is not a true cone. It's something like a true cone, but the bottom of it is straight, and only the top is tilted. And so, I basically developed a mathematical description of the saddle surface that's needed, and I devised a scheme for how to hold the metal part and first machine the top. And this will be a brief taste of what it's like to see the CNC mill run. This is a ball mill cutter. And so the math of figuring out where the ball mill cutter is going to cut, you don't just assume it cuts at the bottom of the tip. It cuts at, a certain angle where it's like tangent to the action. So there, trust me, there's a lot of math in this because we're basically cutting something that's going to sit on a saddle, and it's going to have a uniform thickness above that saddle. And so that's the CNC mill. Then after that part was profile cut, I had a scheme for how to hold it upside down, and another program came along and cut the saddle. And so yeah, this was this was software I developed from scratch. You know, and it's this is the kind of stuff I do for fun, right?
Yeah, that's quite impressive. And just so people get an appreciation, a typical locomotive has hundreds of parts that you're machining and milling, right? Not just a few.
Yeah, okay, I'm sharing my screen, and I brought up the design for the Shay, and as it was loading, it told me there were like over 1,600 components. But most of those components are like screws and things. So, but it is probably true that there's 400 parts or so that I'm actively involved in machining and making from scratch. There's little springs and things, and those are made from scratch. Winding them on the lathe. There's a lot of pictures and information on building the how I made the wheels by cutting them out by CNC. And this CAD, this is using the software called SolidWorks. And I got proficient with using the software after building this Shay. And if I had it before I started building the Shay, it would have probably shaved a year or two off, because every time I went back to the plan, I kind of have to spend 4 hours figuring out, okay, where did I leave off, and what are the dimensions going to be, kind of thing. I kind of got to figure out a mess of dirty marked up drawings, to kind of figure out where I left off and what the dimensions, everything. And now that I've kind of gotten on top of the 3D software, it's just, let me tell you how wonderful it is. I can do something like I just hid the tank lid, to show you this is the butane tank and how it's going to fit. And I can work out the paths for all the plumbing. Look, immediately look underneath the locomotive. Yeah. And plan how the piping is all going to come together with everything having room. And I'm gonna stop screen share, and I'll show you. I've been talking about that Shay, so let's go back to it. And this is let me open up the cab and just give you a feel for. Yeah, it's a real steam locomotive. I got a little pressure gauge, and there's a little lever here to blow the whistle. I love it. It's got a real whistle. There's a little this shaft is the throttle, and I was explaining how it I don't know how well you could see this. It controls a little jack screw and a lever to very precisely regulate the amount of steam. Can you come in from the top a little bit more and show us the throttle? Because you definitely have the throttle that it can grab right there. Yeah. The actual handle that they grab and pull forward and back. What do you call that? Is that I could call it the throttle. They don't pull this. You turn. I'm behind the computer, so I don't know how well you're seeing this. Yeah, I can see the wheel turning. But what's if I screw? Yeah. What's what? What's the lever though to the right of that, or nearer to us? There's a lever that's got a squeeze handle on it. They can pull backwards and forwards. What is that? Oh, this little one down here. Yeah, they can't see it at the moment, but can you? Yeah, that's the whistle. Oh, that's a whistle. Okay. That's okay. That's the whistle. Now this one here. This is the little drain cocks, and I don't know if you're seeing that. I mean, it's kind of subtle what it's doing. Yeah. I'll show you changing the gear direction. You ought to be able to see this pretty well if I got my camera aimed right. Yes, there you go. this is to go in reverse, neutral, and forward.
Okay.
And so you saw a little bit of that in the motor video.
Yes, that's what that
Okay.
is. Okay, that's forward
So
and backwards. Okay. What do you call that
Yeah,
handle that you're moving
yeah.
back and forth? What's that called?
Just the valve gear setting.
Yep. Yeah.
You know, on a rod locomotive. Okay, you're asking kind of a. Yeah, I'm going to tell you what a Johnson rod is.
There you go.
So, you know, the joke is you go into the gas station and they tell you your Johnson rod's bent or something.
Right.
This is the Johnson rod, and on a rod this is a conventional rod locomotive that you're used to seeing in Hollywood movies.
Sure. Yeah.
And that Johnson rod is playing the same role of, you know, it's connected to a lever in the cab to control the valve setting.
Wow.
So
That whole assembly looks pretty complicated too. That's a whole nother story. Did you want to talk for a few minutes about, these hand cars?
yeah. So after I finish the Climax A, okay, let me set the computer down, and this was my next project, and it's an old time hand car, and it's pretty it's very similar to one that's at Disneyland, and I got that I built the hand car, and then a friend of mine said, wouldn't it be cool if you could have a robot run the hand car? And so I first bought a little Robotis Mini. A Robotis is a company in South Korea, and this is a anthropomorphic robot, meaning it kind of acts, you know, with human-like motions. And I programmed it to run the hand car. And there's video segments of that on Flickr and stuff. And what I found out was the robot, the mini robot wasn't powerful enough. And so what I did then was I bought another robot, and I programmed two robots to run the hand car. And they still weren't, you know, powerful enough to really run it, you know, confidently on track. They could run it on my flat shop, you know, floor. And then I, you know, this is like MIT problem solving, right? So then I said, well, you know, on the hand car, when you're at the extremes of the motion, nobody's transferring power. So what if I designed a hand car that had dual cranks, so that when one guy's at the dead point and he's not transferring power, the other guy's at mid-stroke. So I designed and I built this hand car that looks, you know, like something the Sheffield, the hand car company, might have made in the 1800s. And it still wasn't enough. You know, the two smaller robots, even with a dual crank hand car, you know, we're not making the job, not getting the job done.
Yeah.
So then what I did was I bought a more powerful robot, and this is like a robot with the servos are like 4 times more powerful than that little white Robotis Mini.
Yeah.
And so what I did was I used one of these robot kits, and I custom built it in what you see as SpongeBob.
I love it.
So instead of having, you know, all the different servos, I just gave him like you know, what is it, 6 servos?
Sure.
Or the motions that he really needed to do.
Yeah.
And so finally, I've got a robot that can run the hand car. So we need to go back to you know, Flickr.
Sure.
And show that video. You know, COVID interfered with my plans to get down to Houston run the robot and everything. But finally, I got down Memorial Day, and I finally was able to successfully run him. And okay, I don't do this every day, so we're gonna.
No worries.
We got to get.
By the way, a few questions are starting to come in, so in a few minutes we can start to field the questions.
Oh,
if
okay,
anyone else
sure.
has questions, put them in the chat box, and then at the very end we'll open up to the floor. But it would be great to have some in the chat box so we can discuss.
All right, hand cars is a pretty recent thing. Okay, so hand cars, and okay, so this is here's here's a nice clear photo
Mm-hmm.
of SpongeBob. Then this was around Memorial Day, and there we have it. This is a 7.25-inch track at the Houston area live steamers. So I was telling a friend of mine that if you paid a company to develop that SpongeBob robot, they had this, if they scratch and they so you're going to hire them, and they got to scratch build a hand car, and then they got to custom build a robot, and then they got to do all the programming work. That probably would have cost you $100,000.
Right. Sure.
So here we are with it's all for fun.
Well, you got some pretty pithy questions here. I can tell that we have some serious listeners. Let me tell you, the first one is, how do you attach parts? Are they brass parts soldered or welded? That's one question.
Okay. There are techniques to make interesting shapes that are hard to machine. And if I'm making them out of pieces of brass, they're usually silver soldered, or which is actually a misnomer. It's brazing. It's a high temperature silver solder, a hard solder, the way jewelers use. And, it's like 1200 degrees F, I don't know, 1250 F. It's, the things are glowing red when they're soldered. And I've got some fire bricks, and I've got some big torches. And after you silver braze, actually I can wave a torch around in front of you and stuff. So this is actually a medium size torch. For the torch, it uses propane, and it's propane just mixed with air. And this style of torch has changeable nozzles. And so for something like the boiler, it's silver soldered, silver brazed copper pieces. But that's a very common way to create tricky parts, little ladders, strange shaped parts. The footrest at the end of the bumper, those are silver brazed. And then the larger sub-assemblies are typically screwed together. I tap little holes and use little screws. I use a lot of 256 screws. I haven't gone smaller than 0.80 screws.
Tony also asked this question, Ed. He says, I'm building a live steam rescue tug. It has a boiler with a torch that fires it. This takes too long. It runs off butane. How do I learn to heat the boiler with a more compact torch? Any publications or sources for parts?
Oh gosh, he can get on bulletin boards where like-minded hobbyists hang out, and like the people that are serious about like making big locomotives, 7.5-inch, weighing a ton. A lot of them hang out at Chaski, CHASKI. It's like chaski.org. It's bulletin board. And so, and then there's other guys that are more like gauge 1 in the size range that I'm doing. And a smaller proportion of those guys are really knowledgeable scratch builders. And I would, if you wanted to ask questions, I would get on the like Chasky and look for the right kind of forum. And he could, there's probably things that he could do if he's willing to replace the boiler or, put different kinds of burners in there. And even heating up the water before you start is not cheating, like you bring a thermos of water and you dump it in hot. So that saves you time.
So just to be clear, it's chasky.org, chaski.org, I believe.
Yeah, if you just start searching for Chasky message board,
Yeah.
you'll find it, even if I'm wrong.
Yeah, I did see one, chasky.org/home machinist. Home machinist is one, but there's a whole set of different options there too.
Look around at the different forums, and some of them are more live steam and builder oriented.
Yeah. Now this is Dave coming back at us. I have a 1930s Markland's live steam Royal Scotsman HO scale that I inherited from my father. I would like to get it to run again, and I have not found the right folks to help me repair it. Can Dr. Hume recommend a local club to talk to? I did get the train to run 20 years ago when my dad was still alive. Compared to Dr. Hume's Locomotive, this is pretty crude.
Okay. I think you guys are right around Massachusetts, right? So the question is coming from somebody who lives in Massachusetts area, Boston area.
I'm not sure. In fact, maybe at this point, Dave, if you want to talk directly, we can unmute you. I think you could unmute yourself at this point.
Yeah, because there's some active clubs in the Boston area. I think there's at least there always was in the olden days, Pioneer Valley Live Steamers.
I don't know where Dave's located though. Dave, are you in Massachusetts?
Yes, I am.
Oh, you are. Excellent.
So
Yeah.
I would get in touch with your local live steam club, and if you Google around for like live steam clubs in Massachusetts, and look at links from Live Steam and Outdoor Railroading has a website, and there's probably links to clubs. You will be able to find a couple clubs in the Massachusetts area, and then what you want to do is just kind of show up with this thing in a box and talk to the old guys. So.
By the way, Ed, what will people discover in your book, The Climax Class Steam Locomotive? Does it get into some detail on how you do things?
It does. It presents in detail all the drawings needed to actually make that Climax locomotive, and it explains in detail, how to machine the gears, and I'm actually making sure my computer's plugged in. Okay. So it presents a whole lot of information that you don't get just from looking at the pictures on Flickr. Tips for troubleshooting and building and maintenance, and guidance, all kinds of information about techniques you got to understand, like painting, but it, I don't want to oversell it, because it's a pretty technical book. It's not for everybody,
It won't have all the answers.
And the other piece about it is, it's got another story going on, which is like this takes place at Live Steam University, and so I got like main characters who make mistakes, and then the teaching assistant shows them an easier way to do things or how to fix their mistake. So by making up this storyline about Live Steam University, I'm able to present this different material kind of in a unique way that maybe makes it less dry than me just lecturing at people.
Oh, that sounds interesting. I have to tell you, I didn't know anything about live steam before I saw your article. It's fascinating to me that there's a whole bunch of people out there that are invested in this, and you clearly have devoted a big part of your life to this, and it's impressive. It really is. And you've only shown us maybe 3 of your locomotives, but you've got a number more of them too, as well as I understand, right?
Yeah, I've got, I got my Climax B is sitting on the shelf in a case.
Yeah.
I did put the Heisler out on my saw table, so you might have seen that in the background when we.
Yeah. So there are the cases on the left. True. There's the cases.
Yeah, that's.
I love that. You have them all put away nicely. Yeah.
I'm doing this like I can't even see. Okay.
Yeah.
That one's
Yep.
there. That's the Climax.
I love it. That's
And
great.
just to okay, let me get the camera down a little. Andrew indicated that these do have a ramp feature, so when I'm at the track, I can roll the hot locomotive, down the ramp right onto the track.
I love it. That's great.
And
I see you got it moored pretty nicely. You have it. You have a special, I don't know what you call it, but braces in place to hold the locomotive intact, so it can be shipped. I imagine, or at least carried.
This is clamps
Mm-hmm.
to secure it.
Yep.
So it doesn't bounce around. And this is the aluminum that this is made out of. You can actually buy, I think, most of these sizes at a place like Home Depot.
Really? Oh.
Yeah, and this is like ordinary 1/4-inch steel that's been machined, and
Mm-hmm.
again, this can even be found at a hardware store. And although it's true that I do use industrial suppliers, for most of my shopping,
Mm-hmm.
but the carrier becomes like a tray, to hold little parts that I take off, and there's little recesses for the wheels.
Oh yeah.
And because of the clamps, like I can tilt it up to
Yes.
get at the bottom for lubrication and stuff.
Sure.
So it takes about 3 weeks, 3 or 4 weeks to make the stand like this.
Mm-hmm.
I kind of got it down to a science now.
I bet. Yeah.
And I've got the wood cases. That's part of that 4 weeks.
Mm-hmm.
So I've got of course now that I'm doing all the CAD drawing, I've got actually got another locomotive planned.
I was going to ask you, yeah, what's next on your agenda?
So these are like all the drawings, and it's going to be a old time small shay.
Mm.
And so this is very detailed drawings of the 600 parts or so.
Wow. Yeah.
And this is even information on how I'm going to clamp and make the wheels.
Mm.
And how this is getting into cutting gears. I got a fancy burner thing going on. So it's it's hundreds of pages of design work. And the thing that makes this model unique is I've got a scheme where I'm going to use an ordinary purchased copper T, and then standard pieces of copper to make the boiler. And the person making this will not have to they'll not have to form copper. They won't have to do all this hard boiler work where they're bending copper, by pounding it around wood forms.
Yeah.
And the thing that makes it possible is I've got this this is 3D printed metal that I've had made at Shapeways using a very expensive metal printer. And so this is like the top of my firebox. And I'll bore it out precisely to mate with the standard copper. And then there'll be a smaller smoke tube, like 3/8 copper pipe coming
Wow.
out for smoke tubes.
How big will this train be, this locomotive be?
I
I almost said train.
Yeah, you did. I think this is actual
Actual
1-to-1 scale.
size. Wow.
Yeah.
Now, is that the same gauge as the other trains you've built?
It is.
It
It's
is.
like it's like an old time. I kind of went back in time with Kozo did the more modern Climax.
Mm-hmm.
So I did the old time Climax A, and Kozo did a more modern Shay. Now I'm going back and doing, is a Shay with as small wheels as I can manage.
Mm.
So
By the way, typically, what do these locomotives weigh?
okay, are you asking about the models or the prototypes?
Yeah. Oh no, the actual models. Yeah.
Well, I could tell you that Heisler, I steamed it up on Saturday,
Mm-hmm.
and I actually strained my back.
Oh my
Because I
God.
was like lifting, and moving around. So it's probably at least 45 pounds.
Wow. Oh my God.
Sitting there in that container.
Yeah.
And so I actually think I put the size and weight information maybe on some of the Flickr photos, because
Mm-hmm.
you don't know how much it's going to weigh till you're done. And so I know on some of the locomotives I may have indicated the weight in the comments on the Flickr stuff.
Well, thank you so much, Ed. If anyone wants to ask any questions as we wrap up, feel free to unmute yourself and fire away. Otherwise, we'll wrap it up at this point. Any final thoughts, questions, comments? Well, Ed, thank you so much for your time. I got to tell you, this was really exhilarating for me to just see all the fine work you're doing and the detail and the effort. Dave says thanks so much, by the way. Very impressive. Really something that I'm glad we've recorded, because I think lots of people will want to see it over time, and definitely will give it to you so you can do whatever you want with it. But this has been a really fine, as you suggested in the beginning, be one of the best presentations ever. It certainly was.
Right.
We really appreciate it.
This was a guy and shop oriented one, right? We didn't, no fashion talk.
Right. No, it's not food. It's not fashion. It's hardcore mechanical engineering, industrial design.
Yeah. All really the locomotives are painted black.
I wanted to ask you something. One final thought is, where were most of these locomotives originally designed? Were they exclusively American, or were there other countries that were good locomotive innovators?
That's a great story. These are these geared locomotives. These are right out of the American heartland, because
wow.
The Shay was developed in Michigan by a lumberman. He took a marine motor and put it on a flat car, and he could more efficiently pull his logs out in winter. And then the Climax was developed in Corey, Pennsylvania, and the Heisler was the only geared locomotive developed by a professional engineer. Heisler was a Cornell graduate, and so what he did with the V2 engine, and the drive shaft down the middle, is just a really smart engineering. The forces are kind of offsetting each other, and there's the valve gear eccentrics. It drives both cylinders. It's really a brilliant design.
Wow.
So it's something an engineer can love.
Excellent. Thank you so much, Ed. Folks, there is going to be a survey coming your way. Please take a moment to fill it out. The Jenks Center appreciates the feedback, and it's always nice to hear that people enjoy these presentations. And we certainly would love to have people like Ed come back again. And Ed, I just so much appreciate your time, and I'm so glad we connected, and look forward to seeing your next project.
Well, okay. Thanks for having me. So.
All right. Everyone,
Thanks, Ed.
have a great night. Thanks very much.